S is a geometric sequence, so it goes A, AR, AR squared, and so on. But the nth term is then AR to the n minus 1. And we're told the sum of the first 6 terms of S is equal to 9 times the sum of the first 3 terms of S. So the sum of the first n terms is A 1 minus r to the n over 1 minus r. That's typically how it's given the formula, but you could also write it as A r to the n minus 1 over r minus 1 by timesing top and bottom by 1. Sometimes that is more useful to use, so just make a note of that. But for our purposes here, I'll stick with the one that's a bit more conventional. And it's the reason this one is used is because then it leads nicely into when r is less than 1 and you get a convergent infinite geometric sequence, for example. So the sum of the first 6 terms is going to be a 1 minus r to the 6 over 1 minus r. And the sum of the first 3 terms is going to be a 1 minus r to the 3 over 1 minus r. So I'm told this first one is equal to 9 times the second one. This is 9a 1 minus r to the 3 over 1 minus r. Okay, so we've got to solve that. We also are told, and I'll just put it up here, that the 7th term is 360. That means ar to the 6. Remember I said the nth term is this, because I raise r to the power of 1 less than the term number, because the first term is a, it's ar to the 0. So that is going to equal 360. So where we're going with this, we want to find the first term is we're going to now solve for r, and then we're going to sub in. Because actually in this one, the a's cancel out. And also I can cancel out the 1 minus r's. I've just got to note now that r can't equal 1, because I'd be dividing by 0. So now we get, let me just, I just want to talk more about that. I mean, so this formula that we use, yeah, only is valid when r is not equal to 1. If r was equal to 1, then we'd get, it wouldn't really be classed as a geometric sequence. You would just get the same term every single time, A. And you could look that into that as a special case. So you would get the sum of the first 6 terms being 6a, and then the sum of the first 3 terms being 3a, and then we would need 6a to equal 9 times 3a. The only way that could be true is if a was equal to 0, but then we couldn't get the 7th term as 360. So although I'm just dealt with it as a little special case, actually, I see I can rule it out. Back to here. So now I've got 1 minus r to the 6 equals 1 minus, sorry, not 1, 9 minus 9r to the 3. This is actually a hidden quadratic in r to the 3. So I'm going to rearrange r to the 6 minus 9r to the 3 plus 8 is going to equal 0. And you can either do a substitution for r to the 3, let u equal r to the 3, for example, or we can just go ahead and factorize in terms of r to the 3, which is what I'm going to do. So they've got to both be negative. It's going to be 1, minus 1, and minus 8. So r to the 3 is equal to 1 or 8, which means r is equal to 1 or 2. But this is actually why I noted it up here. Okay, we can immediately reject this one. We don't need to consider it anymore because I've already dealt with that special case by itself. And when I cancelled out the 1 minus r, it meant it couldn't have been a solution. So r is equal to 2. Good news. And then I can sub that in. Just got to work out what 2 to the 6 is. Well, 2 to the 6 is the same as 4 to the 3, which is 64. So A is going to be 360 divided by 64, which is 180 divided by 32, or 90 over 16, or 45 divided by 8. Okay, I probably could have got that a bit quicker, but just halved it each time. The answer is going to be E.